Hello, today we're going to look at some examples using our custom cross-section calculator. So I'm going to come here and create a new calculation. I'm in the US standard right now, but this will work as well in Australia, New Zealand, all of our different building standards. So if I go to the custom cross-section properties area here, click on here, let's start with back-to-back channels. So once I create this, we'll see now that it's created. The first thing I'm going to want to do is change my analysis type to none. And the reason we're doing that is it makes the analysis go a lot faster behind the scenes. And then once we're ready to actually get our final values, we can come back and make this the full analysis. So once this is done, I've got my two back-to-back channels. I can go and change these. So if I want to say do another channel, and perhaps I want to do a C9 by 20, no problem, and it updates both of my channels at the same time. I can also scroll down here into the composite section geometry, and if I look at the X shift, I can change this, and we'll see it's quite valuable to do. So if I wanted to have a 1-inch spacer between my channels, I can add 1 inch, and you can see now my channels are split by that much, right? So I can have that distance. If it's a really big column or something like that, I might have 6 inches, so no problem. Again, we'll see these here. So this is where it gets interesting now. If I come here, I'll just do the elastic analysis for now. So we'll run the analysis on these channels. And as we can see, I've got my moments of inertia here, the I value. So if I look, I've got 122 inches to the 4 x-axis, 156 inches to the 4 y-axis. If I scroll down now, however, and let's say I bring this back down to 2 inches, I can look, so 122, 156. Now that these channels are a lot closer, I can see my moment of inertia in the y-axis has significantly decreased, and that's just as I would have expected because my channels are closer, my moment arms are lesser, and so I've got smaller moment of inertia. Similarly with the elastic section modulus, the distance of centroid, the radius of gyration, everything here. On the diagram itself, I can see I've got my origin here in the blue cross. This isn't too useful for this specific situation, but we'll see this in the next example where that comes in useful. I've also got my centroid as well as my strong axis here of bending. Okay, so now that we've looked at these, we're going to look now at a bit more complicated example. So I'm going to create a new calculator for custom cross sections. This time I'm going to select a generic custom cross section. Okay, again, I'm going to switch my analysis type to none for now. And I'm then what we're going to do now is we're going to want to create an I section, but with a channel cap plate at the same time. So I'm going to just go to our still database just to make our lives a little easier. We've got a W12 by 45. That's perfect now. So as I can see, I've got my W12. If I wanted to add now my channel, I'm going to create a composite section. So I'm going to switch this to yes. And we can see now I've got a big rectangle. That's because by default, I've got a 12-inch by 8-inch rectangular plate. Obviously, that's not what we want. We're actually going to want to pull a channel from our steel database. So if I come in the steel section, I can zoom out a little bit, select a C section, and I'm going to select a C10 by 20. So I'm going to go up, and I've got my channel here. It's not exactly lined up the way I'd like it to be. So just looking at it, we're going to want to rotate it at the very least to put it on the right side, and then we might want to shift it as well. So if I come down here, first thing I'm going to do, rotate it by 90 degrees. Now if I scroll up, I can see it's rotated about the origin point here, the blue cross. So now we're here, but we still need to shift it a little bit so that it's properly aligned with our I section. So no problem, we're going to go here. And the first thing we're going to do is the Y shift. And one thing that becomes useful here is I can go into detailed mode, details. And now if I scroll down, I can see I've got a bunch of different parameters. So in this case, we are going to want to move our channel down a little bit so that it's the top part of the web that meets the flange of the I section. So if I come here, I can see I've got my web thickness. So I'm going to click on here. I see I've got my formula reference. If I click TW2, I can even copy just that. And in my Y shift, I'm going to want to move this by minus T underscore W2. And that tells me, okay, it's moved now by the thickness of the web. I can come back up now and I can see, oh yes, it has shifted down a little bit so that it's lined up. Next, I'm going to want to move it laterally so that it lines with the middle of the eye section. So if I come back here and I've got my X shift, in this case, I basically want to center it on the middle of this. I want to center the middle of this channel with the middle of this eye section. So because we've rotated our channel 90 degrees, we're actually going to want to center it on the depth of the channel, but on the width of the eye section. So I'm going to come back here and in my X shift, I'm going to do parenthesis B. So that's the width of my eye section. If I come back up here, B, 8.05 inches. And then I'm going to add plus the depth of my channel, D2. You can see that right here. If I look, D2. And we're going to divide that by 2 so that it centers it in the middle. And if I scroll up, I can see, hey, I've got my channel at the right spot, and I've now got my cover plate on my eye section. So what I can do now that this is done, I can come into this analysis type, and I can choose the full analysis. It's going to take a second to run now. Okay, now that this is run, I'm getting a warning now. Oh, that's probably because my channel here at the tip of the flanges, sometimes you'll see that. We've got a warning because the mesh size at the tip of the flanges is very small and very fine. So it's given us a warning. In this case, because we know that this is the specific case, we're okay ignoring this warning, but it is something that we want to look into sometimes just to be sure that we're comfortable with that. Typically, if there's going to be something really wrong with the mesh, it should be visible somewhere on here. We should be able to see, oh, wow, there's something clearly wrong here. But in this case, we're confident this is fine. I'm going to hide this warning. And now if I look, I've got my cross-sectional area. I've got my moments of inertia, both about the geometric axes and the principal axes. In this case, they don't really change. I've also got my section modulus for positive and negative bending. Similarly, I've got my centroid distances, and I can also see these on the diagram. If I look, I've got my centroid right here. This is my strong axis. I've also got my shear center, my plastic centroid. So all of these are here. So if I go back and keep going, speaking of plastic centroid, I've got my plastic section modulus. So if I'm doing plastic design, it's no problem. I've got these values right here. And I've also got the shape factor. So that's the plastic section modulus divided by the elastic section modulus. I've also got, which is quite convenient here, my torsion constant, so 3.28 inches to the 4, which is very useful when we're dealing with lateral torsional buckling calculations, for instance. And similarly, I've also got a warping constant that I'll be able to use in the AISC equations. Going down now, I've also got shear areas. Now, for something like this, we're probably going to want to manually calculate this just in terms of the web width, but this is a convenient method for more complicated cross sections. And finally, I've got my monosymmetry constants. And so what these do is in some of the equations in some standards, we'll ask for a monosymmetry constant to calculate the lateral torsional buckling capacity. It accounts for the fact that we don't have a doubly symmetric section, which is the generic assumption in a lot of formulas. And on the left here, I've got this. I've also got material properties. If you're in the US, we're not actually doing much with it right now. However, once we have our design function linked with these custom cross sections, you'll then be able to actually link all the material properties directly into the design calculation. And if you do want some really nitty-gritty details, you can actually come down here and see every single value, and you'll be able to use that for your designs if you so desire. So with that, I'm going to end the video here. I hope this was helpful. As always, if you've got any questions, you can use our blue help button right here. You'll see we've got some articles on the custom cross-section calculations, and you can also send us an email anytime you want, and we'll be happy to reply as fast as we can. Thank you very much.